Hi, my name is Jack Lamar. I'm on the ADAS processor team at Texas Instruments, and I want to welcome you to part 2 of our TDA3 EVM video series. In the last video, we went over some common use applications and TDA3 processor specifications. We also talked about how the features of the EVM, paired with TI's software and support ecosystem, make development faster and easier. In this video, we will unbox a new TDA3 EVM and walk you through the setup process. After watching this, you will be ready to run various demo applications and start your own ADAS system development on the powerful TDA3 platform. So let's get started. TI and Spectrum Digital have worked together to bring you this EVM along with various peripheral attachments. In this video, we will focus on the TDA3 EVM board and its necessary setup components. Let's take a look inside the box. Upon opening, you will find the TDA3 EVM board, DC power supply adapter, JTAG adapter, Aptina imager adapter, 2 GB micro SD card. And please note that the 12-volt board power supply and USB cable are not included in the box, but will be required to run demos. With these contents, we are ready to set up the EVM in preparation for running various TDA3-based ADAS demos. This portion of the video will walk you through the setup steps in the Vision SDK TDA3XX user guide, which can be found in the directory shown on the screen. Once Vision SDK is downloaded and installed, we're ready to start building the application. The first step in this process is to navigate to the Processor SDK Vision folder and go Vision SDK, Build, and in here you'll see rules.make file. Open that file in your favorite text editor, and on line 49 you'll see make config equals TDA, and this might not be 3XX, just make sure that this is 3XX for the purposes of this setup. Now we need to set the XDC path to environmental variables. To do this, open up command prompt and type path in all caps equals, and this is where you need to type the path of the XDC tools folder. I've already copied it, so I'm going to paste, and then you need to type :path, enter. Now the path is set. We are now ready to build the application. Inside the command prompt, go to the Vision SDK build directory and type gmake space -s space -j depend. When you run this command, it'll compile the application. Then, you'll run the same command, but without the depend, and this will finish the compiling process. Now that the application is built, we need to configure the board's UART settings. To do this, you will need a serial communication terminal. In this video, I will be using TeraTerm. So when I open up TeraTerm on my PC, I get this window. When my EVM is powered on and connected via USB, I can select serial and the COM port will come up. Press OK, and then navigate to Setup, Serial Port, and here we need to change the baud rate to 115,200. That's the only setting that I need to change here. So everything should be matching this. And press OK, and we're ready to do UART communication. Now we are ready to load the application. There are a few different methods of loading the application. In this video, we're going to use the QSPI and SD card load method since it's the most common. The next step in the setup process is to generate the QSPI writer tools and app image. This involves two simple commands. The first one is gmake space -s space SBL. This will generate your Flash writer and your SBL images. The locations of those can be found in the user guide shown on the screen. Then we need to generate the app image. This also is a simple command of gmake space -s space app image. And this will run through a prompt, and then at the end it'll say app image is at, and it'll give you your directory where to find your app image. Now we need to flash the QSPI writer tools to the EVM memory. First, set the boot mode to debug by configuring the switches shown on the screen. Then, open Code Composer Studio and connect the JTAG to the EVM. In CCS, go to View, Target Configurations. Here it is down here. So in here, you'll have to set up a target configuration for the TDA3 XX EVM, and steps for this can be found in the user guide. Right-click, Launch Selected Configuration, and this will take a few seconds. So the configuration is launched, and now we need to connect the Cortex-M4 IPU 1_C0 core. So right-click, Connect Target. So you can see it's successfully connected. Now we need to load the SBL writer tools onto this core. So run, load program, and here we need to go back and find the tools. So I'll start from the beginning. Processor SDK Vision, Vision SDK, binaries, apps, TDA3 XX EVM BIOS all, SBL, QSPI Flash Writer, TDA3 XX EVM, and it's the top file. You'll open that, press OK, and it will load the SBL QSPI writer image onto the M4. Finally, we need to run this core. To do this, click on the core and press the resume button. This will give you a prompt in the console. So to finish this process, follow these steps. Enter 2 for 4-bit read from flash. Now we need to find the file path to flash. So this is where to find the file. Vision SDK, binaries, apps, TDA3XX, SBL, QSPI SD, opnom, TDA3XX EVM, and here it is, the top one. So for Code Composer Studio, we have to copy this whole path. So get properties, and then here's where its location is. So copy this, into Code Composer Studio, into the console. And to complete this path, we need to enter the file name. Finally, press enter. Offset in bytes in hex is 0x00. Erase options, enter 1. And load options, enter 0. This will complete the process of flashing the QSPI writer tools to the EVM. We are finally ready to load the app image onto the EVM and run demos. To do this, first copy the app image into the SD card on your PC. After you do that, eject the SD card and open your serial communication program. Again, I'm using TerraTerm. In TerraTerm, make sure the serial port is set up correctly. I'm on Con 5, the baud rate of 115200. Finally, insert the SD card into the EVM and press the power reset button. This will run through a prompt, and finally, it will give you the Vision SDK use cases. This completes the setup process for TDA3-based ADAS demos on the powerful TDA3 EVM. Please refer to the user guide for further details. On behalf of Texas Instruments, I want to thank you for tuning in. We can't wait to see how you use our TDA3 processors to create innovative technologies that enable safer driving for years to come. Thanks for watching.